Hey guys, Mr. Bowman here. This is our fourth video in our penguin colony example. We've done our problem, we've done our plan, we've done our data section. We're now moving on to analysis section, which is the biggest and most important part of a time series report. So I had time series on the left, hopefully that looks familiar, and I've got my Word document going on the right. What I'm going to do is I don't need NZ Grapher anymore. I'm going to full screen my Word document. And you can see I got all of the graphs to fit on 2 pages. And now we're going to have a look at the next section. So I know the next section is going to be analysis, so I can start the heading already. And what I'm looking to do now is I'm looking to do all of the key points from the marking schedule, so I know exactly what to write. So marking schedule, we'll start off down below. First one is we need to give a quantitative numeric description of the trend and linked to context with start and end point. So that's another way of saying we need to analyze the long-term trend with start and end points. Okay, so what's next? We need to describe the seasonal pattern. And I just want to note both of these relate, you've got to be relating them to context. And then other relevant features are identified. Features, and what that normally refers to, because it's referring to the residuals, that's normally any unusual points that sit within the residuals graph. Okay, that was the achieved stuff. We now need to look, the appropriateness of the model is justified throughout. So appropriateness of model. I'm going to write all x values, just to remind me of that. So appropriateness of the model, all x values. The next one is the average increase or decrease. And then the one after that, findings are linked to our research. So findings are linked to context-research. And I'm going to put that in square brackets because that doesn't need anything extra. That's add-ons to all of the other points. So what that's saying is every other point above, all of these other points that sit here, all of those need to be researched, and we need to explain or justify why we're seeing what we're seeing. Okay, so that was the first lot. The second bit below relates to the forecasts. So a table of the forecast is included. So we've actually already included that up here, from which forecasts are made. So we need to make a forecast with correct units. And what I do is I suggest we make 2 forecasts here in the off chance you get a little mistake. Okay, and then the next one, forecasts are communicated accurately in context and rounded. So key thing is forecasts are rounded appropriately. So we're looking to do that. A discussion about the reliability of the forecasts. So discussion of reliability of forecasts. And the last point there, an understanding that the forecasts are estimate. So state forecasts are estimates. So this is basically our plan. We've got all of that from the marking schedule. That's the achieved and merit criteria. Obviously, some of us should be aiming to look at the E stuff, but we're just focusing on, well, how would we get to that merit barrier with that? So this is what we're aiming for. Let's get into this. Let's start with the long-term trend. So I'm going to start by setting up my heading for this part. So no point changing that. So let's have a look at our recomposition graph. So the long-term trend is based off the blue line over here. So essentially what we're looking to do is we're looking to compare the start point and the end point to see if it goes up or down. And we can see it starts at 600 and then it does go down. to 418. So that's evidence over this time series data set, the number of penguins goes down. Okay, so overall, the number of penguins in the colony decreases between 2000 and 2006. So that's the first point. That relates to the long-term trend. We now need to justify this. This is because our trend, our long-term trend line starts in January 2000 with 600 penguins and declines to December 2006 to 416 penguins. This is a reduction of 182 penguins, and that was 600 minus 418. So just wanted to note, I knew from the top of my head it was January 2000 and December 2006, but if you go to NZ Grapher that we're on before, we'll just click on here, and what we can do is we can have it just double check our dates. So we can see the very first one, month 1 of 2000, so that's January 2000, which we had. And if you scroll all the way down to the bottom, that's month 12 of 2006, so that's December 2006. And we're just double checking that we got the start and end points right. 600, 412. Without those, you will struggle to pass completely. You may get a resub, but you definitely need those. So we've double checked, and I'm happy with those. The next thing I want to look at within the long-term trend line were there any other noteworthy parts? And we can see from here, from the beginning in January 2000 to the middle of 2003, it was pretty static. If anything, there was a slight increase. But mid-January all the way through 2004, there was quite a significant reduction. And then that continued, again, another little flat line from that. So we definitely need to mention this decline. And we do need to discuss, well, when is that data? So we're just going to follow down. So that looks like the middle of 2003 to the middle of 2004. So let's scroll down. Let's chat about that. So within our long-term trend line, the number of penguins in the colony appeared to be consistent from January 2000 to the middle of 2003. Between the middle of 2003 and middle of 2004, we can observe a significant decline in the number of penguins in the colony. Following this, our data resumes its consistent numbers until December 2006. So just recapping what I did there is I basically mentioned it was pretty unchanged, and then it went down, and then it went changed. So I discussed what was happening with that long-term trend line. So the next step, we've discussed the long-term trend line. We now need to think about this point. We now need to link our context or link our observation with some context or research. Okay, so let's get Google going. So on the right-hand side, I've got Google, and I already had a look. I've already Googled why penguin numbers declined in 2014. So it was pretty descriptive. If we go back to our graph, where is it? So we can see there's a clear decline there, and it was interesting to see. So the first thing I had a look at was have a look at the headings. Is there anything specific about 2004 and penguins? I couldn't see anything overly useful. So what I did is I went onto Google, and on this I found an article, and I found this interesting graph from climate.gov. And what it did is it talked about the loss of sea ice taking its toll on Adele penguins. And we don't know if it was Adele penguins that we were investigating, but we can see a very big decline here. And if you have a look at this point here where the Gentoo penguins overtake the other ones, if you have a look down, well, that's probably about 2004. So I thought this graph did explain why, particularly at 2004, there was a sudden drop. And you can kind of see in this range here, that was definitely the more dramatic drop of our graph. So I then had a look and I researched why. And what happened was climate change was basically taking its toll. And the algae fed on the swarms of Arctic krill, which are the main source for the Adele penguins. So what was happening was something else was eating the Adele penguins' food, which meant it struggled to survive, or they struggled to survive. And that was put down to the warmer temperatures. So we can see the sea temperatures were rapidly warming. That meant the algae ate the krill. That means the Adele penguins didn't have much food. And why the Gentoo ones rapidly increased, and that was because Gentoo penguins, they are invasive and they're normally in warmer regions. So because the sea temperature is rising, that is making environments that were more suited for the Adele penguins, that's worse off for them and better off for the Gentoo penguins. So that's why I think we saw that bit of a blip, particularly in 2004. So I'm going to use this article to explain this point about my long-term trend and why there was a blip in 2004. So let's chat about this. So back on here, so a 2015 article by Jessica Blunden explained the relationship between Adele. So let's scroll down to make sure I spell that right. There we go. So we can see Adele penguins and Gentoo penguin numbers in Antarctica. She suggests that warmer sea temperatures resulted in more algae. Oh, right, algebra out of force of habit, but more algae. This algae impacted the swarms of Antarctic krill, which was the main source of food for Adele penguins. As a result, their numbers dramatically fell around 2003/2004. Conversely, warmer temperatures meant Gentoo penguins were more suited to the environment, which explains why their numbers dramatically increased. If our penguin colony, so I'm linking this back to our colony, was mainly Adelie penguins, this would explain the dramatic drop we observed in 2003, 2004. So I think that explains the point that I've done. So source, let's state again, we retrieved on 25th of May 2020 from, and I'm going to copy and paste the link where I got this information from. You may also want to put the graph in as well, but I won't be doing that. I don't think it's necessary. Okay, so we've done the long-term trend. We're now going to look at the seasonal pattern. So I'm going to start my new heading here. So the seasonal pattern, let's scroll up to our seasonal effects graph, and I'll actually bring this back. So our seasonal effects graph here. So on the left, every year, 2000, 1, 2, 3, 4, 5, and 6, you can see in these labels up here, we can see all the years individually labeled. And we can see each year follows a pretty consistent pattern. And what this graph does, it averages the points in January to tell us that on average, it's about 125 over the trend line. And what we're going to do is we're going to use the averages on the right-hand side just to discuss the seasonal effects of the penguins. So I guess the first point is I'm actually going to copy and paste this graph down below so I can refer to it as I'm typing, and then I'll delete it later on. So I've got my graph on the right-hand side. So seasonal pattern. So we're chatting about a typical year, not a specific year. So for a typical year, January would start at approximately 125 above, or 125 penguins above the trend line. And I'm just going to clarify, the colony would start in January at approximately 125 penguins above the trend line. So I'm just linking it back to my context. This dramatically declines to 250 penguins below the trend line in March. So just observing, I did skip February, and that's because I don't really want that key point there. This is followed by a dramatic increase to the 5th month, which is May, to May, which is approximately 150 penguins above the average. So I'm just mixing up my words. This is followed by another dramatic decline to June, where the number of penguins in the colony is at its lowest at approximately 340 penguins below the trend line, or below the long-term trend, we'll say this time, long-term. And then finally, there is a steady increase in the number of penguins in the colony. And what I'm referring to here is this was our lowest point June, and it basically goes all the way up until December. And that looks like it's about 450 above the trend line. So finally, there is a steady increase in the number of penguins in the colony. until December, where it peaks at approximately 450 penguins above the average. And then just going to note, in a given year, we would expect the number of penguins in the colony to be above average, and then we're going to state the months in January, and then the 5th month was May, and then that looks like October, November, and December. November and December. Conversely, we would expect the number of penguins to be below the trend line for, and then just looking at our graphs, all the points below the trend line, we'll just list for those: February, March, April, and then we skip to June, July, August, and September. So I think that pretty sufficiently adds up or sums up the seasonal effects graph. So the key points, we mentioned the start and end point. We've mentioned the dramatic declines, and we've also mentioned the lowest point and the highest point. And that was in the big paragraph. And then that little paragraph, we just summarize, well, when is it above and when is it below? And that gives us our starting point. We now need to describe, well, why is this happening? And for that, we need to do a little bit of research. Okay, we're going to switch back to Google, and we're just trying to figure out, well, what's the yearly cycle of a penguin about? So we're back over here, and we just need to hopefully be able to explain some of the comments that we just made. So let's write yearly cycle of penguin in Antarctica. And hopefully this is going to give us some good information. And it looks like, well, it's not a great source, but it looks like Wikipedia is there. So this is about emperor penguins, but let's see what it does. And it did note about the reproductive cycle. So maybe this is all about breeding as well. So let's just see where that was. Okay, and let's have a look at our graph just to see if we can match these up. So the reproductive cycle of the penguin starts in March, and believe it or not, March is this point here. Okay, and at this point here, all the mature penguins travel to nesting areas, and that probably explains this big jump here. So between March and May, that is all the basically mature penguins who are ready to mate, they're all going to make their way to the colony. So that's probably a good explanation of the March to May. So let's start this down. Or let's start writing this down. So the above seasonal effects can be explained by the reproductive cycle of the penguins. As a starting point, between March and May, mature penguins come to the colony for breeding purposes, hence why we observe a dramatic increase in the number of penguins in the colony between March and May. So that explains the first jump just over here. So let's keep reading. And if we scroll down, I did read before The females lay one egg in early May or June, and that represents a significant portion of the body weight. And the key thing is, after laying, the mother's food reserves are exhausted and they immediately return back to sea for 2 months. So I would suggest what this big drop is. So basically, the mothers lay the egg in May, and then they're all back at sea. So all the females leave the colony, leaving just the males to supervise the eggs in that period. So that definitely explains this. So we can say that. So this is followed by a huge decline in penguin numbers, where after the female lays the egg, they return to sea for up to 2 months. So we've explained that, and that's this here. And then what happens after this? The females slowly come back, the males are there, and the new penguins are born. So that explains that big spike following that. So after that time, the females come back, and between these, the male, the female, and the baby penguins are all in the colony at the same time. After this time, and then I'm right, in July onwards, the females begin to return to the colony, which explains the colony increase between July and December. During this time, the females return, the males are present, and newborn penguins begin to develop. And I think that explains the seasonal effects quite well. So we do need to reference that source, retrieved on 25th of March 2020 from, and I'm going to link my source. I shouldn't really use Wikipedia, but I'm going to this time because it ended up being quite a good resource. So that explains the seasonal effects. So I'm going to delete that graph. And the next step is, well, are there any unusual points that I want to discuss? And for that, we want to have a look at our recomposition graph. So I'm just going to zoom in, and what we will be able to see is there are a couple, or there's actually one unusual point just up here. We're not really sure what that is, but it's clearly outside the unusual point train tracks, we'll call them. So what I'm going to do is I'm going to navigate back to NZGrapher to find the exact date of that unusual point. So back on NZGrapher here, we're on the recomposition graph, and we can see that point that we're interested in there. And we've been told that it's May 2005. So that helps us that. So in May 2005, it's definitely unusual, and we can start chatting about that. So that's the residuals element of the recomposition graph. So let's get this back. Okay, so the residuals component of the recomposition graph tells us that there was an unusual point in May 2002. And at this point, I just want to look at, was it unusually high or unusually low? So let's have a look at the graph again. So we're going to, well, actually, we'll go back to NZGrapher to have a look. And we'll get the big screen going. So at this point here, we'll have a look up here. And then we can see the raw data was a lot higher than the prediction at that point there. So at that point there, the raw data, it was a lot higher than what we would have expected to happen. So let's write that down. Okay, at this point, the raw data was significantly higher than what our model would have predicted. And we need to have an attempt. Why do we think at May 2002 there would have been a lot more penguins than our model would have suggested? And we need to do some research to find that out. So just gone to Google, and we're just going to Google May 2002 penguin data to see if anything comes up. This is very specific, so I'm not actually too hopeful in finding any reasons why. Potentially what we actually can see is in May 2002, so it's probably not a coincidence. So I've already seen that, so let's Google May. There you go. So in May 2002, two huge icebergs halved a shelf, and for some reason this made there were more icebergs. Oh, there you go. It certainly added to the dramatic effects. Oh, there you go. So I was shocked, but I actually found a reason. So for some reason, two huge icebergs assisted the breeding of Adelie penguins, and that caused a higher than usual numbers in that area. So that's very interesting. Wouldn't have guessed that in the million worlds. So I'm going to start writing. My research shows that in May 2002, there were two huge icebergs which assisted the breeding success of Adelie penguins. This may explain why we have observed an increase or a higher than expected number of penguins in the colony in May 2002. So our source retrieved on 25th of May 2020 from, and we'll be able to copy and paste that. So I'm actually quite shocked that I was able to find an article that explained the exact point in May 2002. But again, that just adds evidence that we are probably looking at Adelie penguins, which we weren't given that context at the beginning. So very happy with that find. So let's get back on here. So next step, we need to chat about the appropriateness of the X values. And let's get that heading in. This does relate to the residuals, and what I'm going to do for this point, I'm actually going to copy and paste the residuals graph, even though I just deleted it before. So this is the recomposition graph. It includes the residuals. So below I include the recomposition graph. And what we're actually going to do is we're going to analyze point by point just to see where the prediction is good, where the prediction is bad. And what it means by all X values is we're going to go along all values of time. When is it good and when is it bad? So just following our line. So going down here, it looks pretty good. Going up, it still looks good, 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 looks good. And our first blip, we can see a major deviation just there. And we follow our lines on, and we can see another deviation up here, a little deviation down there, and everything else is fairly consistent. So what we've actually done is we've identified 3 points on our graph where if we made a prediction, we wouldn't be too happy with that prediction, but would actually be surprisingly confident about all of the other predictions in our graph. So what we need to do is we already know that this point up here is May 2020, so May 2002. We do need to find the dates of these bad values to be able to look at. So I'm going to go back to NZ Grapher, go into full screen, and what we can do is we can see, so we've already got that. These points here, if you have a look, that point there, well, that was December 2003. And down below here, what point is that? And that there is March 2004. So December 2003, March 2004, they wouldn't lead to good results. So let's write that down. So May 2002, December 2003, and then March 2004. Those were all of those points, and I wouldn't be happy at those points. So what we did is we're going to state that I have compared our raw data with the seasonally adjusted trend line to determine when our model fits our raw data. And then the key thing is we just want to communicate that we're confident there are very small residuals at all points in our graph apart from those three. So we can see there are minimal residuals across all points. Maybe we'll be specific, across all months between January 2000 and December 2006, with 3 exceptions. So our model would not be a useful predictor in May 2002, December 2003, and March 2004, because the residuals are significant enough to observe a difference between our raw data and our model. So I'm pretty happy with that. So that looks at across all the X values, and we've identified those 3 points. And what I'm going to write is, I'm just going to write C below, and then we'll make sure that graph stays in there, and we've identified those points there. So the final thing we're going to do for this video, I am going to switch the forecasts to another video just because this video is on the longer side. We now need to chat about the average increase or decrease. And what I am going to do is I'm going to put the average increase or decrease within this long-term trend line. So on average, there is a decrease of XXX per year. So XXX penguins per year. And I'm just going to go ahead and calculate that. Just do my working below. So if we scroll up, our start point was 600, our end point was 418, and it was over 6 years. So we're going to go 600 minus 418 divided by 6. That comes to 182 divided by 6, which is 30.33333. So what that tells us is there is approximately 30 penguins leaving the penguin colony per year between those 2 years. So we're going to update that. 30 penguins per year, working below, and then we're going to write rounded to whole number. This tells us there are approximately 30 penguins leaving the colony per year between January 2000 and December 2006. And I'll just put a little tab in there just to show them working. Okay, so let's go back to our list. We've now done the average, increase, and decrease. And finally, as we've been going, we've been linking and trying to explain things with context and research, so I'm confident I can delete that one there. That leaves the forecast, which by this line in the marketing schedule, it's kind of its own section, and we'll discuss that in the next video. So a long 40-minute video, but hopefully you can see how I did the analysis section. I looked at the long-term trend. I explained what was happening with the long-term trend throughout the period. I figured out the average change per year. I researched and explained what I saw in the long-term trend. I then looked at the seasonal pattern within a year. I used months because it was monthly data. I then sought an explanation as to why these seasonal effects were happening, and it ended up being related to the reproductive cycles of the penguins. I then found out there were some unusual points in May 2002, and to my surprise, I found out that two huge icebergs actually assisted the breeding success of Adelie penguins during that time, which might have been why we observed the higher than expected number of penguins in May 2002. And finally, I chatted about the appropriateness of the model, and I was found out that our model would not be a useful predictor for these three dates because the residuals were significantly different from our model. So hopefully you found this video on the analysis section useful. This just focused on the first half of it. Pay attention, listen up for the fourth video on the forecasting one. Okay, guys, and we'll see you in the next video.